internet looks clean to us, but beneath that polished surface is a chaotic mess of div tags, tracking scripts, and styling code. When you feed that raw HTML directly into an AI model, two things happen. First, the AI gets confused by the noise, which triggers heavy data hallucinations. Second, you burn through your API budget processing thousands of useless characters. For years, developers have tried to parse this mess using XPath and CSS selectors, writing rigid, highly specific rules to pinpoint exactly where data lives on a web page. The fatal flaw of XPath is its extreme brittleness. If a target website updates its user interface and moves a single block of text by 1 pixel, your entire data pipeline breaks. We are currently trying to power highly advanced, autonomous AI agents using fragile, decade-old scraping techniques. Traditional scraping tools struggle to convert human-facing websites into the high-density context that modern agents require to function reliably. Firecrawl solves this by acting as a web context engine. It abstracts away all the complexity of data scraping, proxy rotation, and rendering behind one single API. Instead of writing brittle XPath rules, Firecrawl uses prompt-driven extraction. You use natural language to tell the API what structure you want, and the engine figures out how to extract it. The output natively translates complex websites into clean, LLM-optimized Markdown and perfectly structured JSON data. This bar chart shows the exact cost difference. When you compare raw HTML token usage against Firecrawl's Markdown output, the volume of data drops immediately, resulting in a 73% token savings. For developers, this means deleting thousands of lines of bloated parsing code from your repository. By stripping away the formatting noise before the data ever reaches your LLM, the model can focus entirely on the actual information, producing highly accurate, reliable responses. Cutting token costs by 73% dictates which AI applications are actually viable to build and run at scale. Getting clean data from a static page is one hurdle, but the modern internet is heavily gated by dynamic JavaScript and complex user interfaces that block standard extraction tools. To bypass these barriers, Firecrawl engineered a feature called Interact. Under the hood, the engine invisibly manages headless browsers, like Playwright, while seamlessly rotating proxies so your requests never get blocked. You don't have to configure any of it. Before extracting a single line of text, Firecrawl autonomously clicks buttons, scrolls through infinite feeds, types into search bars, and waits for elements to load. Once you have this extraction engine, the next challenge is connecting it directly to the brain of an autonomous AI agent. They bridge this gap using the Model Context Protocol, or MCP. This is a standardized, secure way to connect external tools directly to AI models. With a single command line installation, you grant your AI agents native, real-time capabilities to browse and extract from the entire web autonomously. Firecrawl allows agents to navigate the web and retrieve structured data without a human manually preparing the dataset first. Developers can move away from maintaining custom crawler scripts and managing proxy rotations manually. The accuracy of an AI system depends directly on the quality of the structured data used to feed it. Engineering teams can now redirect hours spent untangling web code toward building their core logic, like Advanced Retrieval Augmented Generation, or RAG, applications. By turning the messy web into pure context, your models spend their processing power actually thinking about the data, rather than trying to parse it. If you found this helpful, hit that subscribe button to catch our next review. See you next time.